Okay, we are going to do I think it's 7.3. They reordered the book. And this is on separable differential equations.
Maybe I just
Okay, Matt, you should have your workout. I'm going to have you guys do the problems. And you guys, this is really important. This has been on the exam on the free response, I think, every year. And it's the AB component. Well, so last year it was the AB part. Remember we did the double bubble. We'll finish yesterday's FRQ. Some people did. Oh, but I graded that one, and I know you should know how to do it, and there were students that did not do very well on their AB portion of that test.
I just wrote down.
Yeah. Okay. So if you know what a differential equation is, then this isn't as bad. What is a differential equation? Kevin, do you remember what it is?
Can equate a function.
Oh, I know it.
I know you guys should know it.
Equation involving derivatives. The solution is a function.
There you go.
He's so good. And he's a good runner. Oh, right there.
Okay.
Well runner, Specca.
Okay, you guys. I gotta give them. Oh, you gotta get those corrected back to me. What is a separable first order differential equation? And I have it written down for you, so you don't have to write it down. A separable first order differential equation is one in which the expression for dy dx can be factored. That implies multiplication as a function of x times a function of y. You can't have a plus in there. So yesterday we did dy dx equals x plus y. I can't separate that. There are other ways to solve it. I believe it's called an integrating factor. That's how we can do it. So it has to be a product. That's all you're responsible for. So if you see something like this, you know you can't solve it. Okay? And we're going to separate the variables. Now, did I give you that in there? And what we want to do is get the y's together on one side and the x's on one side. So in this case, I would cross multiply. So dy is equal to some function of y times some function of x times dx. And I don't want the y's mixed up with the x's. You have to separate. You get a point. If you don't separate your variables, you're done. And it's usually a 5 or 6 point problem. It does hurt. And we don't look any further. If the variables are not separated, just plain done.
That makes it easy for you, though.
It does. But it's more fun to get a perfect paper.
Especially when it's probably...
Especially when it's neatly written. Yes. So it's kind of fun, and we'll be grading, and we'll be chatting with each other while we're grading, and then you'll hear people go, oh, I got a 9. It's not often that we'll get 9. We'll find 9s out there. Okay. Then we just integrate both sides. You know what? I don't even think I want to do the example. I'd rather just go like to some AP problems.
Yeah, let's do it.
And that one's just not even that interesting. So this one's a nice one because it's similar to AP problems. I didn't like the first one very much. So let's do this one. dy dx is equal to x squared y. And then I've got a lot of AP problems. But I'd like to finish yesterday's. I know some of you did finish yesterday's. So what we're going to do is we're going to multiply by dx. So what's a differential equation? An equation which involves derivatives, and a solution is a function. So what are we solving for? Y in terms of x. And this is dx. In this case, there is no particular solution. So it makes it a little bit harder. So now what are we going to do? I really like this one. Divide by y. Well, I have you do some AP problems, but just to make sure we get this right. dy over y, I'll go slow, is equal to x squared dx. And you get a point for just doing that. Depending on how hard the integral is, you might get 2 more points on doing the integration. So what are we going to do next, Sam?
We're going to integrate.
And what is the antiderivative of the left side? ln of not y, absolute value of y.
So in this case, how do you know? Would you write it to plus or minus?
Mm-hmm.
You do, right? Plus
You will do plus or minus. Let's get there first. There isn't one.
How do we solve for C?
We don't.
Oh.
Okay, what's this going to be? X cubed. Well, I want to hit this one because this one's kind of important. Plus C. Now, you get a point for the integration. So this would be worth a point. And if you do it wrong, you don't get that point. Even if you do it wrong, you still get your point for adding C. If you don't add C now, nothing, you're done. This is 5 points.
Right there, that's 3.
That's 3. If you don't put the C in, you're going to get 2 out of 5.
That's so stupid.
No, because it's too hard to grade and you don't know what you're doing. You need to put the constant in. You have to do that. Well, we can make one up if you want. Do you want to make it go to, let's make it go to 0 and then y0.
Then you have to go.
Let's make it go through that. Okay?
But then you have to solve it. I just want to check our answer.
Well, we want to solve this.
But we want to make problems.
We will. This is,
Solution, guys.
we will. This doesn't take very long. How do you undo a natural log? You exponentiate each. Now, this is what we're talking about in terms of the grading. Okay, guys? This is e to this whole thing. So this is e to the natural log of the absolute value of y.
You don't have to show that stuff. You can't just go after that.
I want to make a point here. I want to show you what the mistakes are when people take this exam. That's the reason why I'm doing this. There's a lot of stuff here. This is going to be the absolute value of y. You must have the absolute value. Now, if I had initial conditions and I put the initial condition in, I get a point for trying to do it. Did you hear that? Trying to do it. Even if I come up with the wrong answer. And then you get a point for solving. So this is equal to, and this is what I saw. Okay, I hesitate to even write it down.
Don't write
Plus C. Or I saw this too.
Oh. No, it's times C.
Yeah, that's the reason why I'm going through this. It's this, absolute value of y. It is. It's one of those things that's repeated year after year. And because it's e to the m plus n, it's equal to e to the m times e to the n. So this is times e to the c. We've had the advantage of having done those Taylor polynomials and actually learning our exponent laws a little bit better. And you could call that whatever you want. I mean, if x is 0 and y is equal to y0, then I would get the absolute value of y0 equals e to the 0 times e to the c. So what's e to the c? Absolute value of y0. Right? So the absolute value of y, if I want to be correct about this, is equal to y0 times e to the x cubed over 3. And there are two solutions to this. You have, no, e to the c is y0, because this is just 1. So y is equal to y0, e to the x cubed over 3, or negative y0, e to the x cubed over 3. And the way you decide if it's the plus or the minus is you have to look at the initial conditions. So if it had been 0, negative 2, for instance, then I would have to take the negative 1. Because this is all going to be a positive number. I think it's coming. Okay?
Wait, which one was that, Ben?
If this had been the initial condition, 0, negative 2,
Wouldn't it be the positive?
then it would be the negative. No, because this piece right here is always positive.
Okay.
That's positive. So if I'm going to substitute in 0, negative 2 has to equal y0 e to the 0. So y0 has to be a negative 2. The initial conditions determine if it's plus or minus. And we're running into them on some of those AP problems. You ran into it on the multiple choice quiz I gave you.
Oh.
Okay.
Wait, go back to that.
Okay, let us work on this.
Would be the,
Yeah, do you have it in your packet? I don't know.
wouldn't it be the positive one?
No?
For the
does matter.
Yeah, it does matter, but you just made up. So then why?
If I made this, if I took the positive solution, then my answer would be y. You're looking at y0 being a negative number. The result is it has to be negative 2 e to the x cubed over 3. That's what you're saying, Sam. Yeah. But when you solve this, and we'll do an AP problem, you'll see where I have to go back and look here to make sure that I have a negative sign out in front. You'll see it. So let's try this one. This is 2003, number 12. Is it in your packet or not? In this one? No. In this handout today.
No.
It is.
Oh. Oh, that's it. This is multiple choice.
That's pretty easy though.
Yeah, we'll do FRQs. They're yellow. Some people lost those. You might have lost yours yesterday. You were here yesterday.
E.
It is E. So if you read it, it says the rate of change of the volume, which now tells me it has to be C, D, or E. Can't be A or B. I'm going to throw those out. Read through all the answers, by the way. It's directly proportional, which means that if time increases, volume increases. This is directly proportional. That's a differential equation.
I know, it's
Not solving it. But to the square root of the volume,
you could do this if we're not going to do different.
yes. Which of the following is a differential equation that describes that relationship, which would be E? But you have to read it carefully, because when you start reading this, that's the square root of time. That's inverse here. This is an inverse one.
They just throw the cane there to press you up.
No, proportional. So if you make $10 an hour, that K value is 10. It's the slope. Hmm? Okay. Here's one.
You ever figure that out? They don't sell lunch for that.
A curve has a slope of 2x plus 3 at each point of the curve. What is the equation of the curve if it passes through the point 1, 2? This is a differential equation.
Okay, let us work.
Not if kids wanted to take a tangent line and put 2x plus 3 in for the slope. That's not what we're doing. If it has a slope, what's slope? Slope equals what? M equals dy dx equals 2x plus 3. This is not autonomous, but it's still nice. Because it's just x's. So you should try it. And it's going to go through the point 1, 2. Now, this is a multiple choice question. It's not terribly difficult, but if it were a fair response, it'd be worth 5 points. Unfortunately, it's not that easy on the free response. Okay, can we go on? Next one I have is 2008.
Hang on, I gotta get
Yeah, these are in color.
Come on.
And there's Euler in here. We don't have to solve this.
Yeah, we do. Oh, no, we don't.
Oh, no, we don't.
Can we solve it anyways? So it's fun.
You have to use partial fractions to solve that.
Yeah.
So that's the reason why you don't solve it. Might have been an X life would have been nicer. Monday we do have the lab reserved. Remember the software we had last year? I don't know if you are interested in the software or not. And we need to do the logistic. No. We're going to be doing exponential growth and decay. But you pretty much know that stuff, I think. And then Tuesday, I don't see you. Wednesday, I'll see you and you get to sleep in on Wednesday.
I don't.
Some of you don't. And then, why do I have that on there?
What? How far away are you?
You know, Marcus, I missed the beam test.
Well, I did not do a very good job on this. I thought I caught everything. Anyway, Thursday's the lab, and so there's no review day, but your test is Monday, followed by the following Tuesday, because we do have a lab.
Wait, why do you need to be in a lab?
Because we have that software, but it reviews the AB topics. We don't have to use the lab. We will be sharing it with Mrs. Hersman's class. So if we're going to use the lab, we should only use it for the first half of the hour.
This is Hershey's AB class?
Mm-hmm. Because we overlap.
Those children are weak of time.
Okay, do we have an answer yet? You're going through 3, 2, and 0, 8. Oh, this is not. Who wants to come up and put their answer up there? Matt?
I love how you're always looking at him.
Well, he's got his head down. Well, this isn't bad. F of 0 is 8. Yeah, it says this is what we did in 2008. They haven't had a slope field since then.
How do you not know how to do that? So easy. Just follow the lines.
Okay, 0, 8. That's this one. Just follow the directions.
That's how many points is that?
Probably 2. We'll find out. Or they even put the point on there for you.
How do you not get more than lines?
I wasn't a reader then, so I don't know. We have to read the problems carefully because on D, it's saying what's the range of F. And the particular solution for F is this one. I don't care about the bottom half of the slope field because that's not F for my particular solution. So when they talk about in D, what's the range for F, they're talking about for the function that goes through this point. What's the range? No. It's going to be 6 to infinity. Is that 6 there? Or not infinity. What's the range? Sorry. We don't go up infinity. Where do we go up to? Just look at the picture. We go up, because remember, t is greater than or equal to 0, so we can't go to the left side. So it's 6 to 8, and do we include 8 or not?
Yeah.
Yes. I fell for 2. I don't think it's worded very well. It's just the y values, only for the function that goes through 8, not for the other one. I just looked at all of the functions and said, oh, it's everything except for 6 up to 8. Okay, Sam? Question? Let's check that. Okay, 6 to 8, 1 point for the answer. That's it. Now, remember how to do Euler? Let's do Euler.
Make that chart.
Yeah. I'm going to pause this and give you a chance to try it, and then we'll grade it. Okay? Makes only 2 points.
I forgot to make a chart. You do stab EX.
Okay? So do your Euler chart, if I remember. It's the tangent line. So it's n, and then this is your x value and your y value. Are we starting at 0, 8? Where are we starting?
Starting at t equals 0.
T equals 0, and I want just that function at 0, 8. So it's 0, 8.
X is 0, y.
Yep. And it's the equation, here's how you remember it. It's the equation of the tangent line.
Is that 0?
This is 0. So it's y sub n minus 1, or 1 before, I'm sorry, I did that wrong. It's y sub n. The new y value is equal to the one that you just used, n minus 1, plus, I'm not done, the slope, oh, I don't have to, but we can put it in there, I just forgot it, times the step size. This would be x minus x1, and that's the step size. So do you see the tangent line there? So you can remember how it works? You don't have to have a chart. I would look for the answers. Well, we'll not look for the work. So this is 8 plus, and I forgot to write the slope down, y over 8, 6 minus y.
Baby, you need a real attitude adjustment. Do you know that?
Yeah, right. What's your address?
We'll give you a
Okay, you guys, shh, what's the slope?
Well,
It's 8 over 8, and then it's 6 minus 8, so it's negative 2. And my step size, did they tell us? I'm sure. Oh, we want 2 step sizes to get from 0 to 1, so this is a half. Okay. How many more do you have to do? I got to get to 1, don't I? I gotta do one more. So we should do it. Watching isn't gonna do you any good,
How do you
man.
do this in your head?
I don't. I write it down.
7 8 times. Who would you get a clock?
So it's just.
Oh, I get a clock. So let's see what you have. 7 plus, what's the slope there? Okay, negative, and remember, you don't have to simplify. Times a half. So it's 7 minus 7/16. It's not a calculator problem. What number is it? 6. Not a calculator problem. You can leave it 7 minus 7/16. Who cares? But we can do that. If I take 1 away from the 7, it leaves me 6. And 16/16 will leave me 9/16. And you're done. Told you, they're not going to make you do too much. Okay, let's see what we got. 106/16. Whatever. It's the same thing. In fact, I wouldn't even bother simplifying it. I would leave it the way we have it here. Okay. The second, you guys can do this, the second degree Taylor polynomial. Let's go ahead and remember how to write a Taylor polynomial. I hope the last 2 years the Taylor problem was like using cosine and sine of x. And they even gave you what one was. It was easy, but and the scores were high last year. But I don't think it's going to be that easy this year.
Oh.
Okay, it's hard to say, but we will do lots of Taylor polynomials. T of x. Now, this is centered where? At the origin, right? Okay. Well, let's look. It says about t equals 0, so it's centered at the origin. And it's going to be, and I'm going to let you do this, it's f of 0 times x minus 0 to the 0 over 0 factorial. Do you remember the formula, Marcus?
Yeah.
What's the next one then? F prime of 0, x minus 0 to the what power? First power over 1 factorial. That one's pretty easy still. And what's this next one, Justin? Put your phone away or your game away.
Take it away.
Oh, yeah.
Yeah, I could.
No,
Give it. No, it's mine.
But you'll put it away, please.
Let's go to the wall.
Okay, what's this one?
Never get it back. F double prime of 0.
F double, this is, Taylor polynomials aren't hard.
This isn't hard.
No,
Oh, hard.
over 2 factorial. Well, I know what f of 0 is. What's f of 0? 8. This is 1, so I get 8 plus, I can find f prime of 0, because I have the derivative.
0 factorial is 1.
0.
Yes. 0 factorial is 1 by definition.
Huh.
Plus, and then it's the second derivative, that one you're going to have to do some work on, over 2 factorial times x squared. So, 5/8. Oh, here we go. Huh? I just put the clock there.
Yeah, what?
Times 1/2
I don't think you're
x squared. Okay, I'll see if it's right.
Face the fact.
Okay. Nope, it's not right.
Give you like
The girls.
No, it's still not right.
Isn't it negative 5 fourths?
Mm-hmm.
I thought, well, it was next to 5 fourths, and then you have to divide that.
No, I think that's including
You
it.
just write it out. You don't
Five
have to
fourths.
They don't make a mistake. Whoops.
They don't make no mistakes.
Let's go look.
They
The
are
second derivative should give you this.
They take you up back.
So we have to do that, huh? So it's 5/2. Now you get a point for doing, no. It's 1/8. Oh, did you forget the dy dt?
Should get back in, dude. Just go back.
You have to do dy dt.
Derivative of
why
y.
is
If y, whoops,
Oh,
sorry.
Holy crap.
Okay, so we have dy dt
Performing
is, and you got probably a point for the chain rule, even if you didn't get to the final answer. What is it, 8 over y? No, y over 8, right? 6 minus y. So the second derivative, you guys, Matt? Shh. Okay, it's y over 8 times 6 minus the derivative of y with respect to t. Plus 6 minus y times the derivative of that, which is 1/8, times dy dt. And what was dy dt? We already knew that. It's negative 2, right? So this is 8 over 8. This is 6 minus a negative 2 plus 6 minus a negative 2 divided by 8 times negative 2. Oh, did I do that right? 6 minus y, 8. Okay. And you could leave it like that.
No, you can't.
Why not?
Because I don't want.
As a reader, I'd rather have you come to the answer, but on the other hand, you're safer doing that. Okay, how many points was that? It was 4 points for the Taylor polynomial. And what problem was it? Was this number 6? Oh, I forgot that.
Nice catch. Can you run this catch?
No.
It's like when you take the derivative of this part, doesn't 6 go?
Wait.
Yeah,
Oh, yeah, you're right. That 6 isn't there.
Kyle, why are
Thank
you
you.
looking so fancy?
Okay.
so it's still,
The answer is very good. Is 5/2. That's what you should get. Yeah, and they have it right here. I just had. Is that negative? Yeah, that's right. So I'm going to guess that you're going to get a point for remembering the chain rule and the dy dt. And that's all I can do is guess. Because I don't know. I didn't grade this one. What problem is this? This is 6. Look at number 5.
I work at 5.
Is there any Taylor polynomial in that? This may be the only Taylor polynomial there was in this year. I don't know. I think that'd be crazy. Okay, here's one. Here's another one.
It's a Friday.
I don't care. Let's do 2011. Let's finish last year's. So let me have to find it. Remember, we didn't do that yesterday. We did order. So I'll bring up yesterday's smartboard and let's finish that one because that's the one that was really not very good. Yesterday's we did it. It was 2011. I lost my clock.
No, we can't separate that, right?
Yes, you can.
What is your deal? It works really well.
Okay, we got some time here. So let's do this problem. It's dy dx equals 1 minus y. You cross multiply. Always do that first. And now, how do you get rid of the y's? It has to always be a multiplication problem, Justin. You can work on another free response question. Oh yeah, I remember the test. It's not easy. Because I get these people who are doing nothing. Okay, what do we do next? No, because I have y's and x's. We have to get the y's on the other side. You're always going to be multiplying, dividing. I know, I'm redoing it because I'll show you where the mistakes are. I graded this problem. So we were okay here, so you get 1 point now because we separated the variables. So that's 1 point. And then we're going to integrate, just like you said. What's the antiderivative of that? First we'll do the natural log of the absolute value of 1 minus y, and it's negative. And a lot of students did not have the negative. They lost that point, but then I followed through with their work to make sure everything else was right. Although it is an easier problem. How do I know that it has to be negative? If I take the derivative of this, I could do u substitution, or if I take the derivative, I have to multiply by negative. And this is equal to what? X Okay, so you get one more point because we integrated, and you're done if you don't put C in, because C is not going to be right. I found it easiest to do these is to put the particular solution in right away, rather than solving for Y. I like to find C. Oh, what is the particular solution?
F of 1 is 0.
F of 1 is equal to 0. Okay, so I get a point for trying to find C. X is 1, so it's minus the log of the absolute value of 1. And the absolute value has to be there because sometimes that ends up being a negative number. And that's equal to 1 plus C. What's the log of 1? So C equals negative 1. Okay, here's the next problem. Now, we have 4 out of 5 points. You are pressed for time, and you have not done another problem. You've got 10 minutes left. I'm not going to bother with the 1 point here, because this is 1 point to solve for Y. I wouldn't do it.
Really fast.
Now I have 40 minutes left, so I'm done with everything. I might as well do it and get my point, right? Well, what did students do? They did this.
No. What?
They distributed the negative 1 inside there.
Power of negative 1. Natural.
I know.
By the power of
And that's even worse, actually. Not worse, it's right. You could do this. It's the natural log of 1 minus y to the negative 1. You could do that, but then that's harder to solve for y. Why don't we just divide by negative 1? That would be a little easier. Then it's the log of the absolute value of 1 minus y equals, if I divide by negative 1, then this is going to be a minus x plus 1. That's a lot easier. Otherwise, I have to worry about reciprocals. Now, how do I get rid of the log?
Raise both sides.
So it's e. So e to the log of this is the absolute value of 1 minus y equals e to the minus x plus 1. I saw a lot of this. First off, don't simplify. This is what I would call simplifying. I saw a lot of that. Yeah. So don't do it. Just leave it. Just, who cares? Just leave it. So I'm going to put a big red X. It was kind of sad to look at that. Okay, and now we solve. And so, and Sam, this is what I meant by, you really look here, minus x plus 1, or 1 minus y is equal to minus e to the minus x plus 1. Because I want to make it clear. Solving for y here, it's y minus y is equal to minus 1 plus e to the minus x plus 1. And if I finish solving for y, y is equal to 1 minus e. And then I check. But Sam's not listening. What was the point it went to? 1, 0? Does this one work? If I put in 0 equals 1 minus, oh no, I have it backwards, don't I? Is it 0, 1? Help me out. 1 equals 1
0.
minus,
No, you had it right before. That's fine.
it's 1, 0? So 0 equals 1 minus, and then this is e to the negative 1 plus 1. Oh, okay. So that works. I don't have to do the other one then. If this, because what would this be? This would be my, and make sure you cross it out, equals minus e to the minus x plus 1. So y equals 1 plus e to the minus x plus 1. And now you test it again, 0, is that equal to 1 plus e to the 0? No. So what I would do then is just cross it out. Don't erase, just cross it out. This is the answer. But you got to check it. If it had been the other way around, you know, a different answer, I would have had a different, I would have had to use the other answer.
Whether it can show like 2 ways of work or something.
If I were to not, and by the way, they say not to box things, but if I had just left this and had left this,
You don't want me to buy
no.
Why?
Because sometimes the answer is further down, and we read all the way through the problem. So if you box this, but the answer's down here, we have to take that as your answer. So if you don't box it, you'll read all the way down and say, oh yeah, you got the right answer, and we move on.
Just box your answer.
Yeah, but that might not be the answer to the question.
Okay, and the other thing is, do you guys care if it's a pen or not?
No, we don't care.
Like this whole
Don't. Or do you guys kind of like, oh, this guy wrote pencil on the document?
No, there's no rules on that.
But like if you're reading one that's all in pencil and you're kind of tired, you're
Doesn't matter.
oh, I'm just gonna be a grumpy who knows.
No. You guys, we have back readers. So, okay, so how does this work, you guys? Pretend you're all readers. Guys, don't waste my time. You're all readers, you're sitting at your table and you have a partner, so you have partners there, and you're reading stuff, and then we turn these in, and then we have what they call a table leader. So I will be your table leader, and I'll take your grades, the exams you've graded, and I will grade them also. And if we don't agree, then I will come and talk to you and say, here's why I think the points should be here. Now, the table leaders are very experienced readers. They've been doing it at least 6 years. Okay? So, usually whatever they say goes. But sometimes you'll have an argument and say, well, no, I read it this way. And then you will talk about it. If they still can't agree, then they go to the problem leader. And if the problem leader doesn't agree with anything, then they go to the head guy.
Hierarchy.
Yeah.
How many sites do you want to?
Oh, yeah.
Where is it?
Kansas City.
Always championship?
That's where I've been for the last few years. It was in Colorado once.